what we have in this case is a group of equations that we need to first put into our coordinate plane. So what you should do is draw these lines into your coordinate plane. We have y equals 5. Y equals 5 is a horizontal line. Whenever you have y equals 5, all you have to do is find the 5 point here and then draw y equals 5. So I drew that line. We have y equals negative 4. So find the y equals negative 4. 1, 2, 3, 4. Y equals negative 4. If I could interrupt your conversations and have you pay attention to this, please. This might be a test problem that you get. So I have an upper bound kind of and a lower bound kind of. You take this first equation. You have a positive 1 intercept, and you have a slope that's negative 1. So that means down 1, right 1. And that's enough to draw this line. That's y equals negative x plus 1. And we have y equals negative 3x plus 2. So from there, your slope is negative 3 over 1. And your intercept is 2. So I could go to 2 and then get negative 3. 1, 2, 3. And I get a 1 here. And now I have two triangles that intersect here. Now, what can you tell me about these different parts here? Say that again. They're vertical angles. So this angle here is congruent to this angle here by vertical angles. So if I label that point A, B, C, and that's D and E, I can say that angle ACB is congruent to angle EDC or ECD by vertical angles. Now, another question that we're going to run into is how are we going to prove that these sides are congruent to each other? Because if I want to figure out if two congruent triangles are congruent, I need to be able to figure out that their side lengths are congruent. The problem is they intersect kind of in the middle here. So what we can do is we can find the intersection point here of this triangle, and you can get y equals negative x plus 1, y equals negative 3x plus 2. And if we find an intersection point, these two should be equal to each other. So y should be equal to y. So 3x, negative 3x plus 2 should be equal to negative 1x plus 1. I'm going to add a 3x to both sides. You get 2 is equal to 2x plus 1. Subtract a 1. 1 is equal to 2x. Divided by 2. Divided by 2. X is equal to 1/2. So I know that's at 1/2. And if I went into the first equation, y is equal to negative x plus 1, y is equal to negative 1/2 plus 1, which is 1/2. So I have the point negative 1/2, negative 1/2. C is at negative 1/2, negative 1/2. A is at negative 4, 5. B is at negative 1, 5. D is at is at 2, negative 4, and E is at 5, negative 4. So now we can find distance formulas for each of these. That's 1, 2, 3, 4, 5. That's 1, 2, 3, 4.5. That's 1, 2, 3, 4. 1, 2, 3, 4. So that's 4, 4. This one is 1, 2, 3, 4.5. 1, 2. And this one is 1, 2, 3, 4, 1. So that's at 4. That probably should be at 1. That's at 5, 4.5. Actually, that's not at 5. That's at 4.5. 4.5. So that's at 4.5. And that would be at 4.5. So I have two lines here. One's 4.5, 4.5. This one's 4.5, 4.5. So what can you say if two segments have the same horizontal and vertical components? Those two sides are congruent to each other. That's 1, 2, 3, 1, 2, 3. These two sides are congruent to each other. And these two sides have the same horizontal component, so those two sides are congruent to each other. So we can say by side, 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 the two triangles, triangle ABC, is congruent to triangle A is corresponding to point E, B is D, and C. So when you're dealing with the triangles in here, draw the picture and figure out the lengths as best as you can. It's easier to do in a it's a lot easier to do in a calculator. So once you're able to figure out that the triangles are congruent, you can say that all your corresponding sides are congruent. So this is kind of a messy way of doing this, but it's kind of doing the Pythagorean theorems from there. So you can write a paragraph proof saying that you calculated Pythagorean theorems for all of them and you found that the sides were congruent. And so we were able to get side, side, side. Or even just side, you could use side, angle, side as well. Because we did have vertical angles, you could do side, angle, side. So you can do both of those ways. And that'll get you to the answer you need it to be.